6.8, we're analyzing graphs of polynomial functions. Actually, we'll be graphing quite a bit. So your essential question is, how do you graph polynomial functions? Okay, we've had quite a bit of experience with this, so we're just going to kind of tie it all together. I guess let's talk about roots first. So let's remember that anytime we have a root, so let's see, I'll put graphs of polynomial functions. Okay, do the following things. So first of all, they're going to cross, at a single root. So if I have a single root such as, how about I have the polynomial, I'll give it to you in factored form or intercept form. Well, I know that this is a parabola, right, because it's x squared. I know that it's opening up because my a is positive, and I know that my x-intercepts then are -1 and +3. So if I think about this, about graphing it, let's see, so -1 is one of my roots, and +3 is the other one. And my vertex would be right smack dab in the middle of those two, right? So 1, 2, so it's going to be at x equals 1. And I know it's going to be down somewhere, and if I actually wanted to find it, well, I could plug 1 in here and figure that out. So when x is 1, let's see, I get 2 and -2, so I get a -4. Okay, so I know that this parabola then is basically just this U shape that crosses the x-axis. See, I'll label my axes. That crosses the x-axis at its intercepts. And when it does that, it's a single root. Each of these are a single root, right? That means that they're to the first power. So that means that each of these x-intercepts, the graph just crosses the x-axis. So it looks something like this. And I could, of course, do a better job of this by plugging 0 in as well, which I think I did. I got -3. Okay, so that one's pretty easy. Now, as we covered in our last lesson, they are going to be tangent at a double root or any even root, right? Okay, so I'll go ahead and I'll do a double root right now. So for example, if I gave you y equals x plus 2 squared. Okay, all right, well this one's actually in vertex form, right? X plus 2 squared, and there would be a plus k, right? So my h here is -2. So I know that my vertex is going to be hk, which is actually going to be -2, 0. So when I think about this, the only root that I'm getting from this is actually my vertex, right? Because I could also take x plus 2, set that equal to 0, and solve for my x-intercept, which is -2. Okay, so let's see what this looks like. So because this root is being squared, or this factor I should say is being squared, we know that I have a double root. So that double root is always going to be tangent to the x-axis. I know that this parabola is opening up because, again, my a is positive, and I know my vertex. If I plugged 0 in here, I'd end up at 4 for my y-intercept. So I'm just kind of taking everything that we know and putting it all together for you. Okay, so it looks something like that. So anytime you have a double root or an even root, you're going to end up being tangent to the x-axis. Okay, so that would be, even if I had like x plus 2 to the 4th power, it'd also be tangent. Okay? And then the last thing that we know about roots is that they're going to flatten at an odd root or a triple root. So for example, why don't we do y equals, how about x minus 1 cubed? Okay, so with this one, if you think about the parent graph of this, the parent graph looks like this, right? Something like that. Well, it flattens out better than that, but it looks something like that, and it's centered right at the origin. Okay, so again, now you've kind of got, not that this is really a vertex, but kind of this flattened centered area is being moved the same way that the vertex of a parabola gets moved, right? So my h here is positive 1. My k, it hasn't moved up or down at all. Okay, so that just means that I'm going to take what used to be this and sometimes what I'll do is hey, this is my parent graph. So I'll do that dotted. So I can see, okay, that's what I know my parent graph to be. Just like in a parabola, my parent graph would be something like this. That would be going through the origin, right? Okay, so my cubed parent graph looks like this. And now I'm going to move it over 1. So what used to be here is now going to be at 1. Makes it a little bit more challenging. I can always plug 0 in to figure out what my y-intercept is. So it'll be negative 1. So doing the best that I possibly can with this, flattening out, and then coming back up. Okay, so there's my triple root, or an odd root is going to do this weird thing. It's not going to be tangent. It's actually going to cross through, but it does flatten out. Okay, and a couple more notes about our graphs of polynomials. We're going to talk about the extrema and the points of inflection. So, all right, a little summary here. So the graph of every polynomial function of degree n has at most and this is what we, or hopefully you concluded at some point when we did this does most polynomial graphs exploration, you had a couple of conclusions about your extrema. So the extrema, or the maxes and the mins, you're going to have one less than whatever your highest degree is, right? So you're going to have n minus 1 extrema. Okay, or these are your local maxes and mins. Your book likes to call them turning points. So you may see this instead of extrema, you may see your book calling it turning points, okay? So don't get confused, even though I don't really know if I agree with the word turning points. But basically these are going to be your extrema, or your maxes and mins, okay? And then the other thing that we had talked about, but we haven't quite summarized yet, is your points of inflection. And to me, that's where it changes direction. It goes from like concave up to concave down. So I don't really like calling your extrema turning points because I feel like it confuses it with points of inflection. Okay, so your points of inflection then will be n minus 2. So you're always going to have 2 less than the degree for points of inflection. Okay, let's do some examples. Okay, example 1. We will graph the function. And you want to use everything that you have learned up until this point. So our first function that we will graph is f of x equals x minus 1 and x plus 3 squared. This is always a really nice way to get your polynomials. It's basically in factored form or an intercept form, right? So think about this. This is an intercept form. So we don't have to do any factoring. That's so nice of them. So we know where all of our intercepts are, okay? So the first thing I'm going to do here is I'm going to find my roots. Now, because it's already an intercept form, that's going to make this really simple, right? So I'm going to find roots and plot those roots. Okay, so let's see. So if I set each of these equal to 0, then I know that I'm going to have x minus 1 equals 0, so x equals 1, and x plus 3 equals 0, so x equals negative 3. But negative 3 is going to be a special kind of root. It's a double root. Right? So don't forget that at this double root, it's going to be tangent. So it's not going to cross over the x-axis, okay? All right, so I'll go down to the bottom here and plot those. So that way I give myself enough room to do this problem. I'm going to go kind of high up. So let's see, I'm off the paper here. So I know that I'm going to have a pretty low minimum. So I'm going to give myself quite a bit of room on the negative y-axis. Okay, and I'm going to plot my roots. So I've got negative 3 is one of them. So I'm just going to put a dot there. And then 1 is also one of them. So I'm going to put a dot there. Okay, next thing I'm going to do. You should always be thinking about this in your head. Okay, so step 2. Determine your end behavior. This is key. We've got to know our end behavior. So let's see. If I multiplied this all out, this is an x squared and this is an x, so I'd have an x cubed, and it would be positive a, right? So that tells me that my end behavior for this one is basically going to be down on the left, up on the right. Okay? So when I graph this, let's see if this is making sense so far. When I graph this, I should be starting from down here. This is a double root, so I'm not going to cross through the x-axis. I'm going to actually come up, I'm going to hit it, I'm going to turn back around, and then I'm going to have to get back over here somehow, right, so that my end ends up there somewhere. Okay, so I'm visualizing this. I'm making a picture in my head right now, or even like kind of sketching it out on paper, and now I'm going to make it more perfect. Let's see, let me label that as 1. So the only other thing that I have left to do, because I know my end behavior, I know where they're going to end up, I need to know, like, how far down does this go? What's maybe my y-intercept? How quickly does it grow after 1, right? And how quickly was it growing before negative 3? So those are all things that I can do using, or all things I can figure out using an input-output table. So that's always your last step. Find points between and beyond the x-intercepts. So basically that's just use an XY chart. I'll go sideways so I have more room. Alright, so probably one of the most important ones to figure out is your y-intercept. So what number do I have to plug in to get my y-intercept? Well, that's when x is 0. So if I plug x in, I'll just come up here, plug 0 in, that gives me negative 1. Plug 0 in here, that gives me 9. So I've got negative 1 times 9, which will be negative 9. Okay, so I've got something here. Let's see. About there. All right, and some other things that I could maybe plug in is something else that's somewhere between negative 3 and 1. Maybe negative 1 or negative 2. Why don't I go ahead and do negative 1? Oops, sorry about that. So when I plug negative 1 in here, I get negative 2. Plug negative 1 in here, I get 2. So that's 2 squared is 4 times negative 2 gives me negative 8. So at negative 1, I'm down to negative 8. Okay, so I've got negative 1, negative 8 I plotted. Now, it might be a good idea to understand, what's happening before negative 3 and what's happening after 1. However, to save time at this point, right now I have a really good idea what's happening. I know that my end behavior is going down on this side, going up on this side. Okay, so I'm just going to go ahead and graph this, and then we'll graph it on a graphing calculator and see how close we got. It's never going to be completely perfect, okay, because there's so many. I mean, you would have to like plug in every single point in between every single actual integer here. All right, so I know that x equals negative 3 is a double root, which means that I'm going to come up, I'm going to be tangent at x equals negative 3, I'm going to head back down, I'm going to go through my other 2 points down here, always have a y-intercept, and then I'm going to come back up to the best of my ability and still make it kind of look like a function. Okay, so how accurate did we get? Let's check it out. So I'm going to go over here and I'm going to actually plug the function in. Clear that. This is from our last problem. Okay. So you can plug in x minus 1 and then x plus 3 squared. Okay, and I'm going to graph it, and let's see what this looks like. Probably need to change my window, so I'm just going to go to zoom. I'm going to do a standard window, which is number 6. Okay, and there's our graph. So let's see, does it look pretty close? Well, it certainly does. I mean, I think I've done a pretty good job. I could really zoom in. If I wanted more points, I could even go into my table set, and maybe start at, I don't know, I'll start at 0 and change my table by 1. And I could really just get into this using my table, right? So at 0, I know I'm at negative 9. At 1, I'm at 0. And so on and so forth, okay? And I could go backwards even by going up and finding even more inputs and outputs. And I could even go in between and put decimals. Okay, but I think I got a pretty good idea of what this graph looks like. Awesome. Let's do one more of these. So I'm going to have f of x equals negative 2, x squared minus 9, x plus 4. Okay, and I'm going to go back and look at example 1, and I'm going to follow these steps every time I need to graph these guys. So I'm going to first find my roots and plot those, then determine the end behavior, then find some more points, okay? And I added in here, and if you could do that too, please make sure that you always include your y-intercept. So that's the time when x is 0. All right, so those are my steps. So first step, I'm going to determine what my roots are. All right, well, first of all, let's see. This first factor, I'm going to go ahead and set that equal to 0. And I'll do my second factor as well, set that equal to 0. This one's pretty easy, so if I subtract 4 from both sides, I know that x will be negative 4. This one I have 2 ways of doing. I can factor it, or I can use square roots. Notice that there's no x term, so I can just add 9 to both sides. Or notice that this is a difference of 2 squares, so I can factor into x plus 3, x minus 3. Either way, I'll go ahead and use square roots right now. So I end up with x squared equals 9. How do I get x by itself? I need to square root both sides. So x is going to equal the square root of 9, and it's going to be positive or negative, right? So positive or negative 3. Okay, so right now what I'm seeing is that I have 3 roots. 3 roots seems pretty good because if I multiplied my x's together, I would end up getting x cubed. So I should have 3 roots. Okay? All right, so I'm going to plot those. Probably graph paper would be awesome, but, well, I need to go over to negative 4. Oops, and I'm so off the page. I apologize. Okay, so -4 is 1, -3 is 1, and +3. All right, so now I'm going to think about my end behavior. All right, so going back to this. Well, A is negative, and again, we said that this would be a cubic, right? So if A is negative, then we know that it's going to be flipped or reflected across that x-axis from what we originally would do. So that's the other thing. Looking at x cubed, I know that x cubed basically starts down here, like our last one, and ends up here. But because it's a negative A, it's going to be flipped. So it's going to start up here and go down here. Okay, and it needs to go through my roots. Do I have any double roots? I don't see any double roots here. Do I have any triple roots? I don't see any triple roots, right? Each one of these were a single root. So at each root, it's just going to cross. So now my goal is to find a couple of points. Okay, so let's make an XY chart. Definitely starting, I'm definitely going to need my y-intercept. So when I plug 0 in, that's -9, right? And so I have -2 times -9, that's going to be 18. Okay, and then 0 here, oh my gosh, that's 4. That's huge. So I've got 18 times 4, 72. Wow, that's huge. So, I'm just going to pretend. Maybe I'll make it a little larger, and then I'm going to label it. So I'm just going to say that 72 is up here. Sometimes you just have to do that. Okay, so that's my y-intercept. Okay, let's see. It might be helpful to maybe plug in another point. Let's see, what else can we do? Why don't we do -1? Let's just see what -1 gets us. So plugging in -1 here, I'm going to get -8 and 2. That's going to be 16. And then plugging in -1 here would give me 3. So I'm going to end up with 48. So let's just pretend maybe 48's here. Okay, so let's see what kind of graph we get here. So starting up here, each of my roots is single, so I'm going through them once. I'm going to start up here, go down, come back around. Now, I could figure out how far down to go if I plugged in -3.5. That's a little more work than I'm willing to do right now. So I'm going to go up. And then I know that I need to come back down here. So I'm not exactly sure where it's going to turn around, but maybe something like that. Okay, just because right now this is the highest point that I have plotted doesn't necessarily mean that that is the highest point. Okay, so how could I actually find some of these highest points maybe using my graphing calculator? Let's go ahead and plug this in to the graphing calculator. Got to turn it on first. Okay, so I've got a -2 times, and then I've got a x² -9, and then I've got an x + 4. Okay, so let's get an idea of what, well, first of all, I know that my window needs to be bigger, right, because I know that my y-intercept is 72. So how about if I make my y max 100? Let's see what that looks like. So what I'm noticing here is that even after my y-intercept, it goes up a little bit more than what I'm doing over here, right? So I probably could have been a little bit more accurate going up a little higher, but how was I to know unless I had plugged in 1 or 2, right? I didn't plug those in, so I didn't know, right? I can always get a more accurate graph the more numbers that I put into an input-output table. Okay, let's do one more example. Example 2. Okay, so the volume of a box is given by V of x equals 4x cubed minus 72x squared plus 324x. Estimate the maximum volume of the box. Okay, so volume of the box is given by V of x. Okay, and x is probably going to be one of the side lengths of the box. Okay, I'm not sure what that, I'm not giving you that much information. I could write a whole big word problem here, but really, if we just want to estimate the volume of the box, or the maximum volume of the box, we're looking for where V of x is the largest. Okay, so I'm going to go to my graphing calculator. I'm not even going to think about this without using a graphing calculator. Okay, and I am going to, because if I want to calculate the maximum, I'm going to need maximum. So I'm going to go ahead and punch this in. Let's see if my calculator will turn on. Okay, so I'm going to have 4x cubed, so raise that to the third power, minus 72x squared, and then plus 324x. Okay, so I'm going to get a rough idea of what this looks like, and then I'll probably need to change my window. Yeah. So it looks like I need to go further to the right. I know that this is an x cubed, so I know it should be coming down on the left, and then it's going up, and then it's going to end up on the right. Okay? So you have to understand your end behavior in order to really be able to set your windows well. Okay? So I know I need to be higher on the y-axis and probably further over on the x-axis. I could take a little bit of this side of the x-axis off. So my negative x, I'll go -5. My maximum x, I'm going to probably double that. I don't need to go so far down on the minimum. And my maximum, I'm going to try 250. I don't know, I'm just guessing here. So still not high enough to see my maximum, right? I know the maximum's up here. And if you think about it, your output is your V of x, right? So this is my y-axis, or my V of x. That's what I care about. So I care about where this maximum is. So going back to my window, let's try my y max. Let's make it, how about 450? Again, just pulling at straws here. Oh, I finally get to see my maximum. So I want to know the maximum volume. I'm going to go ahead and calculate a maximum. So again, go to the left boundary, go to the right boundary, and calculate the max. Now, which do I care about? Do I care about the x value? Do I care about like a side length, or do I care about the y value? Well, again, going back to this formula, I'm looking at volume, right? So I care about the y value. So it's going to be 432. Oh, I don't know. What was the units in this? Inches. I should have told you that that was inches. So it's going to be inches cubed. And basically all I'm doing, I got this problem from page 376. It's number 12C. Okay? So you guys can go back and look at this problem if you need to. But I would definitely use a graphing calculator for problems like this where you're trying to find your max volume. There's no reason to graph this by hand and try to figure out where your maximum is. Because as we've talked about before, when you graph by hand, you're just getting a rough estimate. And it's important to be able to do that so that you know what these things look like. But it's also important to be able to use your graphing calculator so that you know exactly where the max and the mins are, okay? One more thing I should go over before I finish is, again, your book talks about turning points. So they're calling this minimum a turning point. They're calling this maximum a turning point. Okay, so those are your turning points. And they're going to ask you to like determine those turning points and then tell whether it's a max or a min. And they're also going to ask you to figure out what the real zeros are. Okay?